Hello again. We talked about the cosine rule last time. This time we're going to talk about the sine rule. It's used in different circumstances and it's applied very differently. It's a different rule. So let's get to it. This is lesson 9.7 and let's get started. Again, I have a triangle and all I know are going to be two angles and the length of the included side. Or if I know the measures of two angles and the non-included side, or if I know the lengths of two sides and the measure of the non-included angle, then I can use the sine rule. So we need to keep straight when I can use the cosine rule and when I can use the sine rule. All right, so there are four parts to the sine rule. First of all, I have to remember that just like before, the angles are labeled A, B, C, the sides are labeled A, B, C, so that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So if all of that is true, then here is the sine rule. A over sine A equals B over sine B equals C over sine C, and most people stop there, but each of those is equal to 2r, where r is the radius of the circle that circumscribes the triangle. Okay, so basically if you want to know in a nutshell when you can use the sine rule, it's when you know side A and angle A, or you know side B and angle B, or you know side C and angle C. That's when you can use the sine rule. You have to have one more piece of information other than that, but you at least need to have what's called an angle side pair. Okay, so here's an example. I have two angles and one side that's not included in between those two angles. So we need to find the length of side C. All right. So since I'm given angle B and side B and angle C, then I can use the sine rule because I have B and B. I'm finding C, so I'm just going to use these two fractions, the fact that B over sine B is equal to C over sine C. All right, and I plug in what I know. 13 over the sine of 81 degrees is equal to C over the sine of 48 degrees. So if I cross multiply, I get that 13 times the sine of 48 equals C times the sine of 81. So if I divide both sides by the sine of 81, I will get my value of C, which is 9.78. Okay. Now, I don't want to go through another example where the side is contained between the two angles, because if I know two angles, then I pretty much know all three. They have to add up to 180 degrees. So I would have got the same answer if I was given that 51 degree angle instead. And I would have done it exactly the same way. I would have figured out angle B first, and then I would have been right back where I started at the beginning of this example. Okay, and here's a situation where now I have two sides and I have an angle that's not between those two sides, and I need to figure out angle A. So I have B and B, so I can use the sine rule, and I will set it up like this. A over the sine of A equals B over the sine of B. And I plug in what I know. 10 over the sine of A is going to equal 13 over the sine of 82 degrees. Again, I cross multiply. 10 times the sine of 82 degrees is going to equal 13 times the sine of angle A. And I divide both sides by 13, and that gets me the sine of A. I need to know an angle, so I need to use an inverse. So A is going to equal the inverse sine of whatever 10 times the sine of 82 divided by 13 is. That turns out to be 49.6 degrees. So that's kind of an example of each situation. Remember, there was the one that I kind of glossed over because if I have two angles, then I have all three. So I kind of combined two examples in one there. If you have any questions, please let me know, and I will see you tomorrow.